All right, so we're going to look at deriving the chain rule by first principles. So the first thing to maybe say is if you're not sure what first principles are, basically first principles allows you to find the derivative of a function. But if you're not familiar with that, this video is not going to make any sense. So I'd probably go off and wrap your head around what first principles are. In a nutshell, if you want to find the derivative of a function, you're basically finding the gradient between 2 points that are getting closer and closer together. So you're taking basically y2 minus y1 over x2 minus x1. Yeah, but then those points are getting really close together, so h is getting really small. Anyway, maybe go off and have a look at that if you're not sure. But yeah, this is a definition of a derivative. So the derivative of some function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x. So y2 minus y1 over x2 minus x1. Hopefully you can notice that the denominator, yeah, x minus x is 0. So we're just left with the denominator of h. But yeah, I've left both here because we might need both as we go through this derivation of the chain rule. So let's have a think. So our goal is to derive the chain rule, and let's just think about what the chain rule is. So the chain rule is just this idea that if you want to find the derivative of a composition of functions, there's a certain rule you can apply, which is obviously called the chain rule. And yeah, we're going to see if we can come up with it through first principles. So basically, this is our goal. So we're trying to find the derivative of something like f of g of x. So the first thing that we might want to point out is that we're going to try and substitute things into first principles. So we're taking the limit as h approaches 0 of f of g of x plus h, because we're still changing h to be a small amount. So we're still evaluating at x plus h. So wherever there's an x, we're putting g of x, but we're also still doing it as h with a small h. Okay, and then we're taking away f of g of x, and then we're dividing by h. Now, this first line might not seem very obvious because you notice in the top line, we're taking x plus h minus x. So what we're doing is we're taking a subtraction of our x values. So why does that equal h? So I suppose what I'm pointing out is this. Why does g of x plus h minus g of x go to h? And this is just something I want to point out quickly because it's important. What I've got here is g of x equals x squared and g of x plus h. And then we've got, g of x plus h minus g of x, which was our denominator. Now, what you'll notice is if h goes to 0, so h is some small change or some change in g, and then as h gets to 0, you'll notice that g of x plus h, which is the green line, goes to 0. So if I keep going, as it approaches 0, it gets close to 0, and then there's no difference between the functions, and then h goes to 0. So if we go back here, we can see that this denominator here, yeah, is essentially the same thing as h approaching 0, because g of x plus h minus g of x approaches 0 as h goes to 0. So it's the same thing as saying the limit as h approaches 0 going to 0. Okay, you'll notice here that I've got multiplied by 1. So what we're going to do is sometimes we do this in maths, we do a little trick, we multiply by 1, but we do it strategically. So what we're going to get is something like this. This first part stays the same. This second part is just the number 1, and we're just multiplying by g of x plus h minus g of x divided by g of x plus h minus g of x. And you'll see why we're doing that in a second. All right, remember that multiplication is commutative. So when you multiply fractions, you can swap the denominators. And that's the reason we multiplied by that. So if we do that, we swap these denominators around. And you'll notice I had the limit of a product of two things. And so what we're going to do now is we're going to have the limit of two separate products, which is a property of limits that you can do. Okay, so swap the denominators, take the limit of each of the two products, and you get this, and you get this. Now, just looking at this right-hand side first, hopefully this is jumping out at you as the derivative of g of x. If you compare this to this, you can see that this is just the derivative of g of x. Okay, so that this right part is going to be just g dash x. It's this left-hand part that we're more interested in at the moment. This is the trickier part. So let's see what we can come up with. We're gonna have to make a substitution, okay? So, and you'll see why in a moment. So wherever we see g of x plus h, we're going to call that a. Wherever we see g of x, we're going to call that b. So this thing here is going to become f of a, because g of x plus h is a, and g of x is b. So it's going to be f of a minus f of b over a minus b as h approaches 0. But you'll notice now there's no h's in here anymore. So we have to think about what happens as h approaches 0 to this stuff. And I can show you what happens. As h approaches 0, a approaches b. Now let's think about that for a second. As g of x plus h, as h gets to 0, as goes close to 0, g of x plus h becomes g of x. So as h approaches 0, g of x plus h approaches g of x. So a approaches b. Okay, so what we can say is, yeah, and now it now becomes the limit as a approaches b, because as h approaches 0, that's the same thing as a approaching b. Okay, so we get this situation here. Okay, again, comparing this to our first principles definition, hopefully you can see that this is the derivative of f of b. Okay, just make that comparison. So, the derivative of f of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So this is just f of the derivative of f of b. And we know that f dash of b and times g dash of x, but we know what b is. B is g of x. So after all that, we get this. We get f dash of g of x multiplied by g dash of x, which is, thankfully, the chain rule. That is what the chain rule says. If you want to find the derivative of a composition of functions, take the derivative of the outer function, leaving the inner function the same, and then multiply by the derivative of the inner function. Hopefully that made some sense. As I said, it's outside the course for VCE methods in Victoria, but it might be interesting, for other applications later down the line. Keep up the hard work with studying.